Welcome to this video on spatial analysis. In this video, we're going to be considering vector spatial analysis, and for the example we are going to demonstrate, we're going to be working on buffers. So let's understand what is spatial analysis. Spatial analysis uses spatial information to extract new and additional meaning from GIS data. Usually, spatial analysis is carried out using a GIS application. For this example, we've been using QGIS software, and you can perform spatial analysis on any GIS software. Now, considering the buffering, the buffer spatial analysis, buffering usually creates two areas. One area that is within the specific distance to selected real-world features, and the other area that is beyond. The area that is within the specific distance is called the buffer zone. A buffer zone is any area that serves the purpose of keeping real-world features distant from one another. The buffer zones are often set up to protect the environment, protect residential and commercial zones from industrial accidents and natural disasters, or to prevent violence. I'm going to give us a little illustration. For example, you have a point, a hospital represented by a point, and one of your consideration is it should be 200 meters away from the road, from a major road, or 50 meters away from a school, or just away from a possible disturbance. All right, with the use of buffers, you can generate maybe, of course, 20 meters buffer will draw a circle 20 meters from the original point. So by that, anything that falls inside 20 meters will have to be dealt with. For example, all right, just like a school, you want to site a school. Most people use buffers for planning purposes. You want to site a school, and one of the criteria would be, let it be 50 meters away from a major road, so that it will reduce noise. All right, so with buffers, you can generate a buffer from the choice location and examine the area, what falls between 0 to 50 meters radius. So that's one of the use of the point buffers. For the line buffer, most times we use it for road construction, expansion of roads. If the government are planning to dualize a road, of course there are buildings by the road. So with line buffers, we are able to know the houses that will be affected when the road is expanded, and then the authorities involved will begin to prepare a compensation plan so that they can adequately make some demolitions and compensate the affected people, and also expand the roads. The same goes for polygon buffers. Maybe you have a zoo, or you have a particular building or security house that you don't want anything to fall maybe 200 meters radius around it. You can also use buffers to generate those things. So we are going to be going straight into our QGIS software to look at how we can use buffers. All right, let's head to our software. Yeah, and we are almost there. Now, this is our software. First of all, we are going to start with the point buffers. So right away, let's add our point vector data, and let me go to my root folder. Okay, just for the purpose of the illustration, I have a folder here that has several points. We are not going to be using all of the points, but we are just going to illustrate how to use a point buffer. A point buffer. Okay. All right. Perfect. So we have our point, and let's find our buffer tools. All right. When you head over to the menu bar, you click on the vector and you come down to processing tools and you click on the buffer. And of course, here is where you get to select which layer. If we have multiple layers here, you now select which layer you want to run the buffer on. And then the distance. What's this one in? Okay, great. Okay, so here is where you get to select the distance. However, before we run the buffer, we already have a warning here telling us that we should project it because it is not in a projected coordinate system. Notice we talked about coordinate systems and how that geographic coordinate systems, they simply help us display the map. But if you want to take measurements and anything of that sort, we will need to put it in a projected coordinate system so that we can have a linear measurement, because here we need to determine the distance of the radius, all right, that we want to create a buffer, and we can't use degrees, so we need to project it, reproject it now into a projected local coordinate system. So let's go straight to that. So how you do that is you come to the layer and you come to export, you save as. Okay, no, I want it to be a shapefile. Let me select where I want it to be stored. Okay, inside the vector, and I want to call it test. Okay, projected. That way. I think now we need to change the coordinate system. All right, and I have WGS 1984 UTM zone 32. That works perfectly for me, and I'm going to add it to the map. All right, so I think I can do it with this for now. Perfect. So if you check properties, you come to general information, you will see that the coordinate system has changed and the unit is in meters, right? Great. I think we are good now. So let's go back to our buffering. Now you see we have meters here, and we can actually now change it to other kinds of measure units to say. So we want to create a point and we want to buffer 10 meters away from it. Okay, or let's make it kilometers, or let's keep it simple, meters, and let's keep it at 50 or 100 meters. Okay, I think we can leave the rest that way. Let's run it. Okay. Okay. So something happened, but it was so small. Let's just zoom in. Okay, so this is okay. So what I'm going to do, let me draw this one on top of it. Now you see And also let me add the base map. Let it make some more sense to us. Wow, and I did this on top of water. Okay. No way. All right, great. So I can't use this example. So let me find another place that is away from the creeks so that I could explain something more meaningful to us. Okay, let's use here. Yeah, still not a perfect example. Let me find another example. I can't be so far away. Yeah, I think this is good. All right, great. Also, I could just bring in the Google Map satellite as well, put it under. Okay, this makes more sense, and I think I want to make this transparent, and the stroke, let me make it red so that we can see. Okay, so you can imagine that I want to put a network mask at this point called IKPA rather, and of course there are safety precautions for it. It should not be at a certain range close to residential areas. So if the guidelines state that for you to mount a network mast, it should be 50 meters away from residential buildings, then with the use of a buffer tool, we are able to draw a radius of 50 meters and ensure that there are no residential buildings around that radius. So that's one useful, that's one very good example of how to use the buffer tool, and that is just for a point. So quickly, let's run off to polygons, to lines first, and then we go to polygons. And let me add my data that I want to use to explain that. Okay, roads. Let me just pick a simple road. Okay, and add. Okay, it has been added. Let me just zoom to layer. Okay, I'll just take simple roads here, and I'm also going to open. Okay, let me use the satellite map and probably change the color to enable us see what we are working on. Red should do, just for the purpose of this illustration. Red should do. Okay, red seems to be. Let me see. Okay, I'm still looking for a perfect example, but let's use this. Come on, let's use this example. The roads are not very accurate here, but you understand. So let's just use this example. So for example, we want to have an expansion of the road network, and of course it's going to affect buildings. Just understand the concept. It's like the data set here needs to be updated. because what is on the satellite map is a little bit different. Okay, perfect. We can still go ahead with this. So let's create a buffer for line. The same method, you go to the vector menu and straight to geoprocessing tools and buffer. Notice before we had a village or test, but now we have roads, and again you need to reproject it to a projected coordinate system so that we can work with it. So let's close it and run off back here, export it and change. First of all, choose the location. I'll call it roads and projected, short. Of course, change the coordinate system here to a projected coordinate system and then add it to the map. Having done that, I want to remove the old one. And change the color to red, and also increase the stroke width. Okay, so let's go back to our tool and let's run the buffer. The road is selected, and let's make it 20 meters. I don't know if there's a road that is 20 meters. That would be too long. It could be. There could be. Let's leave it at 30. And I think we are okay, meters, right? Perfect. Let's run it. So you notice we have the roads increased, and let me put this one back on top. So with this we can say, and also let me make it transparent, a little bit transparent. Yeah. So we can say, okay, if this was going to be the road, there are buildings alongside it that are going to be affected. So the authorities involved will roll out plans for compensation and also demolition and get along with the construction project. This is one of the good use of the buffer. So, and lastly, the polygon. So for the polygon, I have okay, for the polygon, let's make it simple. Let's digitize a building. First of all, we're going to create a shapefile. Let me call it building shapefile, and I want to give it a projected coordinate system at once so that we don't need to change. Geometry type is going to be polygon. All right, it's using a projected coordinate system. All right, I think we are good, and here it is. And now let's, if you remember when we did digitization, let's go ahead to draw this building out. Okay. All right. Now that's good. That's good now. So let's run a, let's say we want to, okay, let's make a buffer for it, just as an illustration, but we have to save our edit. Great. Let's run up to our vector buffer. The building has been selected already. We want to see what lies 10 meters. Maybe the owner of the house doesn't want any of his structures 10 meters close to the house. So, and he plans to demolish anything within 10 meters close to the house. Let's make it 20 so that it will make more sense. Or 30 rather. Yeah. Okay, that's fine. I think we can run that. So as you can see, let me drag this on top. We have, let me make it a bit transparent so that it will make some sense to us. Okay, so we see this building. Let me zoom in more. We see the buildings that are affected. There's a building here, there's a building here, there's one here, there's one here. So he is going to roll out demolition plans, so to give himself more space for his own house. All right. So that's one good example of how to use, one good example and purpose for buffers. Buffers are just used to keep some things away. All right. Looking at our definition, to put some things away. Buffer zones serves as, in any areas, it helps for keeping some features distant from one another. Okay, and buffer zones are often set up to protect the environment, protect residential and commercial zones from industrial accidents and natural disasters. These can also be used in environmental management, where you are trying to limit some impact or some possible incident from happening. So you just push things away. You determine what falls between a particular distance to your property and determine what you want to do with it. So we've come to the end of this video. In the next video, we are going to be looking at interpolation, and which is still part of spatial analysis. See you in the next video. Thank you.